Alright, here's another one. Voltmeter reading, 7 volts. Calculate resistance. Pause it and come back. Alright, so we're looking at the voltage loops to calculate voltage for R1 and R2, calculating the current for R1 and R2, and then we're going to use the current junction to find current junction, so the junction rule, to find current through the meter, calculate the resistance of the voltmeter. There we go. So hopefully you got that. Alright, power, the rate of using energy, right? Power measured in watts. We've got some new equations as it relates to Ohm's law. So Ohm's law, this only works with a constant temperature. So we have P equals VI, P equals I squared times R, or P equals V squared over R. All three of these equaling the same thing. So you can set VI equals I squared times R, or you can set VI equals V squared over R. Either one of those, because they all just equal P. So hopefully these will become useful. Let's look at how much does it cost to run a blender. Blender runs on 5 amps of current on a 120 volts. How much power is it drawing? So we've got I and we've got V. P equals IV. PIV. P equals IV, 120 times 5 gives us 600 watts. There's some estimated wattage for some of your devices at home. You can always look at your devices on the transformer, the little plug that takes alternating current from the wall and turns it into DC current. A lot of students are surprised by the amount of the hair dryer. You got to remember what the hair dryer is actually doing. It's basically a tiny little oven and blowing air really, really fast. So it draws this huge amount of energy. And sometimes you could trip a breaker if you have too many devices plugged in at on the same circuit, in which case you have to go out to the garage or wherever and flip that thing. So these are the estimated watts. A microwave on the low end is 1 kilowatt to 2 kilowatts. If you were to run your microwave for an hour, let's say we're looking at the 1 kilowatt, then that would be 1 kilowatt hour, which is what your electric company bills you in. So your homework now is go look at your electricity bill and see how much are you being charged per kilowatt hour. Data booklet, relevance, here's our power, 3 equations. Again, you can rearrange these as you need. Alright, so what factors affect the resistance of a wire? We have the cross-sectional area, the length, and what the material is made out of. Now imagine you're testing the resistance of a straw while drinking a milkshake. If it's a skinny straw compared to a short skinny straw, or a fat straw compared to a long skinny straw, I think that lets you see how resistance comes into play. So resistance is proportional to the length. The longer it is, the more resistance. And like the harder you've got to bring up that milkshake up the straw, and then the thicker the resistance is inversely proportional to the cross-sectional area. So as the cross-sectional area is larger here, the resistance is lower. It's easier to get the milkshake through the milkshake straw than it is to get it through that little coffee stirrer. Calculating resistance. The relationship between all of these, there's our cross-sectional area. Resistance measured in ohms, length measured in meters, area, cross-sectional area, measured in meters squared, which if it's a circle, it's cross-sectional area, so it's going to be looking like this, and the area for a circle, pi r squared. Resistivity is related to the type of material that you're dealing with, and that's an ohm times a meter. our equation that will relate all of those. Resistivity here, rho, Greek letter rho, equals capital R for resistance, A for the cross-sectional area, divided by L. Resistivity changes depending on the material used. So if we look at different materials, silver, copper, copper we know to be relatively low resistivity. It's used in a lot of circuits in a home building. Copper wires, it's got low resistivity, so it's pretty efficient. Meanwhile, tungsten has a higher resistivity, but it doesn't completely slow down the current. Tungsten is actually what's used in the filament for an older light bulb. And the way it works is the current comes in, goes through the tungsten, but because there's such great resistance within that tungsten coil that it loses a lot of energy to thermal energy, so much that it begins to glow. Light bulb. Try this. Calculate the resistance of a 1.8 meter length of iron wire with a diameter of 3 millimeters. Go ahead, pause here, try it. Here we go. So we know the length is 1.8 meters. Oh, sorry for the bad formatting. Rho, given to us, 12 times 10 to the negative 8 ohm times meter. Cross-sectional area is 3 millimeters. Be careful there. It's millimeters, so you've got to move that decimal point, 10 to the negative third. And that is diameter, so we need to have, it's pi r squared, so we're going to take half of the diameter squared. And then we can just plug in chug into that equation from there. And we should get 0.0306 ohms. All right, number 2. Pause this. Try it again. We've got a current going through a 75 meter wire that is metal alloy with an area of 2.4 millimeters squared with a potential difference of 12 volts was applied across its ends. What's the resistivity of the alloy? So we're using Ohm's law here, and we're using the resistivity formula. So we get 9.6 times 10 to the negative 8 ohms times a meter. We'll stop it there.